let us talk about classes of instructions. We just talked about addressing modes. Now we're going to talk about classes of instructions. We are going to talk about first loads and stores. Okay? And this is interesting, for me at least. You might not find it interesting, but I don't care. Okay, you're stuck. I say to you, you have a CPU, and I say to you, you have memory, and I say the following. A load is where you move information from memory to a CPU register. Okay? So you've got memory, and you've got something out there. Let's say you got, like, BB is sitting out there, okay? And it's just sitting there. And you want to put that thing in A. Okay, so this is register A. So you have an instruction, which is called a load, and you're going to go out, and you're going to grab that and put it in there. Okay? That's a load. Let me ask you a question. Is this the same thing as a read? We're splitting hairs here. What do you think? Okay, you gotta go back a little bit and go, what the hell are you talking about? I'm assuming they're not the same because you wouldn't write this. And you took forever to write and move information from memory to a CPU register. Because I wanted you to soak it. Did it soak a little? Okay, let's push it in a little bit more. Remember, a read is a single memory access. You go to the memory system, you provide an address, and then data comes back. That's a read. Okay? That sounds pretty similar to a load, doesn't it? Except for the following. In order for you to execute a load instruction, what did you first have to do? You had to fetch the opcode, and that was one read. Then you said, I need to go fetch an operand, which let's say in this example is the data, and then I take that operand on my second read and I put it over into the register. So an instruction will consist of multiple memory accesses. You will always read the opcode. There's no way to execute an instruction without at least one read. You will most often read an operand, and then depending on the addressing mode, you will either be done or you will have to go access another memory location and perform a third read. That's the big difference between a load and a store. So the answer here is no, a load is not a read. A load will consist of multiple reads. Let me quiz you here. If I used immediate addressing, immediate, what information is going to go into A? Where is the information that will go into A if I use immediate addressing? It's the operand of the instruction. Okay? If I use direct, where is the information going to come from that I put into A? Yeah, the address that is the operand. So I'm going to have to go read the operand and say, oh, it's an address. Then I'll go out to that address, grab the information, and put it into here. So there's actually two types of loads. In fact, there is a load A using immediate and a load A using direct. Okay? Now that's pretty cool. You know what we need? We need mnemonics because we're not going to be writing out sentences anymore. So what is a mnemonic? Now we have this concept of a full instruction, opcode operand. We have this notion of addressing mode where the operand could be something. It could be the data, it could be the address, or it could be nothing. So now we finally building a mnemonic. What would be a good mnemonic? Remember, do you remember what a mnemonic is? It's just like a word that's kind of descriptive to a human, so not ones and zeros. So it's like letters that describe to us what the thing is, what the instruction is, but it's a direct representation of that instruction. Here is what I might propose to you. Let's make a mnemonic for this load immediate into A called LDA underscore IMM. Is that okay? That's pretty descriptive. You know, LD load, A underscore immediate. Okay? Now, when I do that though, am I done? All I've done is created this thing for the opcode. Do I also have an operand? The answer is yes, because I'm going to provide the data that will go into the register. So I might also have in there something like BB. Okay? Let's make a mnemonic that is also for our direct buddy, and let's go LDA underscore direct. And, okay, life is so good. And in this situation, do I need an operand? Absolutely. I need to provide the address of where to go get data. So I might also go BB. Okay? Let me ask you before we start looking at the actual execution of these things. These two instructions, okay, are written in a language which we call assembly. It is where we write one line of code to represent one instruction. On that single line contains a mnemonic representing the opcode so that we don't have to memorize the codes, and then the optional operand. I have just written here 2 lines of assembly code, and they look pretty similar to each other. Would you agree? Let me ask you a question. After I execute the first instruction, what will be in A? Load A immediate with BB. What will be in A? BB. Because the operand for an immediate addressing is the data that we'll use. Let me ask you this. If I execute this instruction, what will be in register A after I'm done? You don't know, do you? It's whatever's at address BB. See the subtle difference there? All right. This feels so frickin' good that it's time to break this down and look at details of how you execute an instruction. Yes?
When you were first asking about the new mnemonics, I thought it was just like LDA 371, because we previously used LDA. Is it common this level of design to do the underscore and then addressing code right after the mnemonic?
I don't know. That's just what I decided to do.
Okay.
I would say there's no common way to do it. It's whatever the designer wants to do. Okay? But you're right. In it's LDAA, like, yeah, exactly. I just made it up. Okay. I walk up to you and I say the following. I would like to execute this instruction. And it is called LDAA immediate AA. Okay? This is exactly how you're going to type it. Let's assign a code. Okay? Let's assign a code for LDAA. So let's go ahead and assign it a unique code. I'm going to assign it a unique code of 86. Okay? So when I go to essentially compile or assemble this line of assembly code will be converted into 86AA. I tell you that I want to insert this into memory at the reset vector, which do you remember what that is? 0, 0. So here's what this will look like in memory. Okay? I'm going to walk up to my memory system and I want to see some bits. Okay? I see 86 followed by AA. That is what it will look like in memory. Okay? And I want to walk through how you actually execute this. First of all, I hit reset. What is the value of the program counter? Whew! It is 0, but how did we get that? The program counter holds the address that we're executing at. When I hit reset, the program counter holds the address of the first opcode of the first instruction in my program. So in this situation, we hard-coded it to be 0. We will go to 0, 0, and we know that there 86 resides there. Let's walk through all the steps that happen when you execute this. Number 1, I need to go fetch the opcode. The program counter itself holds the value. It is what holds 0, 0. Is that how I read from memory? No. The memory address register is what I use. So I take program counter and I put it into memory address register, and then I read. At that moment in time, who's coming over on the data bus from memory? Who's coming over to the CPU? 8.6. I have just read 8.6. Here comes 8.6, and it's coming over. Where's old 8.6 going to go? We need to store it somewhere. So let's stuff it in the instruction register. So 8.6 is going to go into the instruction register. And now here's something new. When we read that opcode and we retrieve the opcode and put it in the instruction register, you know what else we do simultaneously? We increment the program counter. Why would we increment the program counter? Because we know almost always we're going to read from that next address. We don't even know if it's an opcode or an operand yet. We haven't even decoded the opcode. We don't know what's next. We do know that we will go to that next address once we either execute this instruction or we're done. So then the decode occurs. Program counter is now incremented to 0, 1. So now it's 0, 1. And I decode. What do I learn when I decode it? I learn this is a load A using immediate. Notice at this point we don't know what the operand is. We haven't read it, but we do know, based on the addressing mode, that there is an operand. Not only is there an operand, the operand is the information that I will load into A. So I've learned a whole bunch of stuff when I decoded that. I now say, damn, I wish I knew where the operand was. Ha! Where is it? It's being held in the program counter. So what am I going to do with the little program counter? I need to put it out on the address bus. So I do that by putting it into MAR. Now MAR holds 0, 1, and I read. What comes back from address 0, 1? AA. What should I do with AA? AA is heading into A. I put it into A. But think one more last thing we need to do. What should we do before we end this instruction? We need to increment, yes, the program counter so that that program counter is pointing at 0, 2, which will be the address of the next opcode. How's that feel? How many reads did that take? A read is a single memory access. 2! Why did it take 2? You had to read 86, which was the opcode, and you had to read the operand. How's this feel? Okay. If it feels good, good. If it feels bad, that's no problem. Because you just go over this over and over and over. And then once you feel a little good, we go deeper into the design and you look at it from an even lower level until you are ready to start typing in VHDL to perform all of these different operations to execute an instruction. Whew. How's that feel? Yes. Yes. You ready for another? We now are going to do an instruction which is called load A with direct addressing. Okay. We are going to load A. That means at the end of this instruction, something is going to reside in A. But it's direct addressing. Does anybody remember what the addressing mode direct means? Yes. It means the operand is not the data. It is an address of where to go get the data to be loaded into A. All right? How's that feel? Why the hell would you ever do this instruction? Yeah, this is how you go get information from data memory. This is how you go get information from an input port. Okay? You might say, it's time for my computer to read from an input port. I don't know what the information is down there. If I did, I would have just used immediate addressing and loaded in a constant. I have no idea what somebody put on the input port, but I know where the input port is. Okay? So here's what we're going to do. We're going to set this puppy up as follows. First of all, we've created this nice mnemonic, which is a way for us to have kind of a letter, wordy little thingamajig. Okay, I made that up. Proclamares 2017. Okay. And it's going to allow us to essentially do substitutions for our mnemonic and the code that we come up with. I chose that the code we're going to use is 87. Why did I choose that? Random. Darts in a dartboard, right? Does anyone remember that code? Believe me, you don't need to memorize opcodes, okay? It actually just happens to be what the processor in 371 uses, okay? Total coincidence. All right. 87 will tell my CPU that, hey, buddy, we're loading A with direct. Let's do an example where I choose to use 80 as the address of where I'm going to go grab information. Okay. In this situation, I am going to do the following. So I'm going to say, let's put this at 08 for no other reason. We're going to stuff this puppy into memory at 08, and we're going to put 87 there, which is the opcode. Right after it, we're going to put the operand, which is 80, and then after that, who knows what's there. In this example, if we're going to go load information from 80, let's put some information in it. So down in memory, somewhere else, I am going to initialize 80 to be AA. Okay? So it's there. This is what we start with. All right. If I am ready to go, I come into this instruction, I know the following. The prior instructions have set me up for success by having the program counter point at 08. Program counter is holding that. It is holding the location of where I'm going to start executing my instruction. Okay? What is the first thing that I need to do? I need to fetch. In order to fetch, I need to go get the opcode. Okay? I know the address where it's located. How do I get it? I need to take old program counter and put it out on the address bus. So I'm going to take program counter and I'm going to stick it up into memory address register. Okay? So now memory address register has 08 on it, and that is what is driving the address bus. I now can grab this 87, and here comes 87 on the data bus. So now the data bus is holding 87. What am I going to do with it? It's coming back to the CPU from this read. Where should I put it? It's the opcode. It's what is going to tell me what instruction I'm executing. You know where I'm going to stuff that puppy? I'm going to take that guy, I'm going to bring it right around over here to the left, and I'm sticking that baby in the instruction register. Okay? Now my instruction register has my opcode, and I could decode it, but you know what I'm going to do? I'm going to increment the program counter because I need to tell that program counter to point to the next location in memory. It could be an operand, it could be an opcode. I have no idea until I decode this instruction, but I know I need to get ready for it. So I go ahead and increment the program counter. Okay? I'm ready to decode. Bam! Okay? What did I learn by decoding 87? I learned it's a load A, comma. It is load A with direct addressing. That means the next location in memory is an operand, and that it's an address of where to go get the information to load into A. I learned a whole pile. So we need to first go get the operand. Okay? Frick. Where is the operand located? How am I going to know where the operand is? Program counter. By design, the program counter is going to have it. And look at 09, you say. Well, that does hold it, but that's not going to get us the address. That's not going to change the address bus, is it? So what I need to do is put program counter into the memory address register. So I need to say memory address register is now 09. That allows the address bus to be 09, and here is 80. So now here comes 80, and it's now coming across the data bus. And I got something to think about. The operand's coming. It is an address of where to go get the information, and I have a critical decision. Where do I put the operand? In the memory address register, right? It's not an opcode. It's not going in the instruction register. It's not going into A because it's not the information I'm trying to put into A. It's an address of where to go get the information. So I put that puppy right into the memory address register. Now the memory address register goes to 80. And you're like, holy crap. The memory address register was really sequential. It was like 08, 09. I would have thought it went to 0A, but it didn't. This is interesting because now the address register is pointing down to here, but guess what? In that operation, I got to do one more thing. I just pulled the operand out. What should I do? Almost every time I ask you what you should do, you say, increment the program counter. Okay? You'll be right almost every time. Okay? I'm going to increment the program counter to 0A. And you're like, why the hell would you do that? What does that have to do with going and reading from 80? You know what it has to do? We are setting up where the next location in memory to read an instruction from. We're not done with this current instruction, but I know for a fact that the next opcode resides in this next address in memory, and I'm going to get ready for it right now. Okay, let's finish up this instruction. I now have 80 on the address bus. That is allowing the information at 80 to come over to the data bus, which is now AA. And here comes AA. Where are we going to put it? Into A. That's exactly what we've been trying to do. We've been trying to put the information located at 80 into AA. I say boom to the boom. It's AA, if you can see that. And now I say, am I done? Am I prepared to execute the next instruction? The answer is yes. Think about it. The information has been loaded. AA has now been moved into here. The information at 80 has been moved into there. And the program counter is pointing to the next location in memory, which I know by design is the next opcode. How cool? Yeah.